Hi, friends. Good evening. I really hope you all are doing great and are excited about today's session. So, welcome to this Dynamic CISO LinkedIn Live episode where we invite knowledgeable speakers worldwide to share their knowledge with our open, evergreen LinkedIn community. And today's speaker is Rohit Sehgal, a passionate security engineer at Gojek. And today's topic is Attackers and Defenders Guide to Kubernetes. A bit about him. Rohit is a traveler, author, engineer, and maintainer of several open source tools such as Trash Email. It's a Telegram bot that provides disposable email service. And another tool that is Docker and a RAS tool that can help identify the weak configurations inside running Docker containers. That I think is a very relevant tool for you if you are into DevOps. A bit about him, a fun fact about him. He's the inventor of two patents and waiting for them to be credited to his name. And he also creates really informative security giants at securitygiants.com that I can't recommend highly enough. And I'll also share his website URL so you can check out the cool projects that he's working on. Uh, all right, I hope everyone is as thrilled as I am. And please share your questions in the LinkedIn chat, and I'll take as many as I can towards the end of this talk. So Rohit, if you're ready, let's jump right in. All yours.
Hey, thanks, Bablu. Thanks for introducing me. Let me start sharing my screen
Sure.
and let's get into the presentation that we have. So in today's presentation, I want to talk specifically about a couple of things around containers, basically the attacks and defense scenarios. How is like container environment attacked and what are the different strategies that you can use to defend your container environment? And when I say container environment, it is specifically a Docker container and Kubernetes cluster. So yeah, so in today's presentation, I want to cover very basics of what containers are, what are the orchestration engines that we have on top of containers, what are the basic deployment strategies of orchestrations, and what are the best configuration, what are the issues and configurations and best practices around Kubernetes cluster. After that, we'll move to different kind of practical attacks which are possible with container environments, and we will also see how you can have some sort of mitigation around those attacks so that your cluster or your container environment is secure from attacks. So yeah, I think Bablu has covered a lot about me. So just to brief out that I'm Rohit. I am into the security stream for like close to 6 years now. I started as a developer in security team at Walmart. Then I moved to junior pen tester in Walmart itself. Have experience with Visa as a senior security engineer, and currently I'm working as a staff security at Gojek, which had been merged with Tokopedia. So like I'm in GoTo right now, and I have close to 4 years of professional experience. That's in short about me. So let's get into action, what we have today. And I want to start with very basic introduction about containers. And containers are various, like there are various kind of different containerization platform. And today I want to discuss specifically about Dockers. Docker is a very magical concept which actually packages your application and its dependencies inside a running contained environment, which is known as containers. And this helps your application makes it OS independent and secure. It also gives scalability, and this scalability is achieved through orchestration. And there are a couple of orchestration engines that we have. One is Docker Compose, another one is Kubernetes that we are going to see today. Uh, the next one is it makes your package OS independent by actually wrapping its dependencies around a boundary. So that's basically it's actually packages your application. And the last one is it makes your application secure by isolating your application from rest of operating system. Now, what might happen is like, let's say if your application is vulnerable, the risk parameter or the risk boundaries of your application are reduced so that in case if the application is attacked, the risk boundaries is not propagated across different applications which are running inside same operating system, which is possible, which is very much possible with case of virtual machines. So in short, they are actually similar to virtual machines, but they work differently than VMs. So when I say they are different than VMs, as in like in virtual machines, you have specific resource allocation to guest. Although it is shared, but VM doesn't feel that it is shared. So VM seems like to VM, it seems like a proper resource allocation, which is not the case with containers. So containers uses a concept of Linux namespace and control groups, although control group is also one of the Linux namespace to create a virtual environment for application. So it's a Linux terminology that container leverage, and they leverage those kind of things to make your application some sort of application isolation. And what are different kind of namespaces? We have 7 different kind of namespaces. One is mount, process, IPC, network, user, UTS, and C group. And all these different kind of namespaces provide different kind of functionality. For example, if you pick specifically C groups, which is control groups actually allocates or limits hardware resources to a specific container environment. Whereas mount file system takes care of virtual file system partitioning. Process is for allocating processes to a specific namespace. So all these 7 different kind of namespaces together brings a lightweight container environment, which we call as Docker. So basically, these 7 different namespaces are what creates a specific Docker container. And in one specific Docker container, it is recommended that you run only one specific application. The entire application and its dependency. For example, if I have drawn a web application in this particular case, the web application and its dependencies are actually isolated through 7 different namespaces, and they are packaged in something called as a Docker container. Another thing is, uh, we don't do these kind of namespace forking all the time. There is something called as Docker CLI, which does this for us. So we just issue a couple of commands through Docker CLI, and Docker CLI takes that, perform namespace forking, and those namespace depend on the command that you like trigger. So let's say if you want to target the process namespace forking or IPC namespace forking or network namespace forking, those kind of new different namespaces would be created and would be linked to specific Docker container, and through that we'll have a specific containerized environment. And this is how the container works, which is nothing but the fundamental unit of our modern cluster, Kubernetes cluster, or any other kind of orchestration engine setup. So this is how basically a fundamental unit is created out of it. And there are different ways of creating Docker engines. So, Docker images. Let me tell you a very quick introduction to Docker, because we have to move on to the kind of attacking and defending scenarios in Docker containers. So I'll just give you a very short glimpse of what you can do with Docker. So you can, the installation is very much specific to your host operating system. While installing a Docker, you have to install a couple of components. One is Docker engine, another one is Docker client. So Docker is based upon a client server model. So you have a command line client talking to your Docker engine. I'll show that in detail in coming slides. But yeah, the installation is very much specific to operating system. Once you have that Docker installed, you can fire this Docker run hello world command to see if this hello world command image, to see if this hello world image runs. And if that image runs, basically your installation is perfect. Docker uses the concept of Docker images to actually run a specific container. So here, the case of images hello world. So I have created, not I have created, basically there is an image known as hello world, which Docker fetches from a Docker Hub, which is the repository for all the images, and deploy that application inside your Docker engine. Docker Hub is actually managed by Docker Inc., and you can actually create your own repository there and push your images there for public to use them. So while pushing that images, you have to perform Docker login from command line. So Docker Hub is actually a repository for keeping your Docker images. And once you have your Docker image, so you can actually use it across any machine which is connected to that Docker Hub. You can also have private repositories where you can keep your Docker images. Those repositories are also known as DDR, which is a Docker trusted repository. They are often deployed by organizations to keep their images private. One example of that is GCR, which is Google Container Repository, which is an offering from GCP. So you can keep your private images in GCP instead of keeping in Hub, which is public. The next thing I want to talk about is a Dockerfile. So Dockerfile contains set of instructions which help you build a specific image out of that particular file. So in that file, you write a couple of instructions. Those instructions simply tells that what image that you have to pick, what you have to do on top of that image, and how you have to deploy that specific image, which command that you have to run, and which argument that you have to pass to that command. So those sort of instructions are written in Dockerfile. And then you create an image out of the Dockerfile. And this is the syntax of how you can create an image out of Dockerfile. And once you have that image, you can actually push it to the repository, any repository that you wish. So this was very short glimpse of Docker container. I know it's not sufficient, but for this presentation, I want to keep this to restricted because I want to move to Kubernetes section. That's where we want to see what sort of attacks and what sort of attacks are possible in cluster environment. Okay, so the next thing that comes to your mind before moving into some cluster deployment, which is Kubernetes, that why Docker aren't sufficient? Like they have everything that we need. So why aren't they sufficient? One thing is, let's consider a specific scenario where this particular node on which couple of Docker containers were running went down. So let's say if this particular node goes down, all the applications which are running inside individual Docker will go down. And even if you have restart is equal to always flag set while spinning up the Docker containers, even if the node never comes up, these containers won't pop up anytime after that. So what we have to do is if you see this deployment, this kind of deployment is not fault tolerant. As in, if the node goes down, the containers would go down, and your application will be you will not be able to access your application. So this was a major issue that Docker independently cannot handle. So that's why we need something on top of it. We'll see what that is, but right now this is one of the examples. And although if the same node comes up, the Docker restart will actually trigger it up. But the chances of bringing the same node up are less as compared to uh, spinning up a new node. So we did not have that kind of node management capabilities with Docker. So we had Docker, like Docker engine can manage containers, which are like Docker containers running in single node. But let's say if you have multiple nodes, we don't have that kind of flexibility to control multiple nodes in this particular environment. The next thing was load balancing and replicas. So let's say if I want to publish a couple of replicas for the same application, let's say here I want to publish 3 different replicas of the same application and load balance them for any request that comes in. So this kind of flexibility is also not possible in Docker environment. And this is very commonly known as service abstraction. So we did not have service abstraction in Docker by default. The third one is rolling upgrades, and rolling upgrades specifically with no downtime. So let's say you want to upgrade the application which is inside your Docker, and you want to upgrade it without any downtime, provided that you have a couple of replicas. So this updating strategy is also known as rolling updates, but this is again not possible in case of Docker. And the last thing is distributed workload. So let's say you want to share a specific volume across 2 different nodes, and in those nodes you have 2 different containers running, and they both want to read the volume together. So again, this kind of distributed workload kind of scenario is not possible with Docker. Again, that is the case. So definitely there is a case that we need something on top of Docker which can help orchestrate these kind of thing, and this is nothing but orchestrator. So we have a lot of orchestrators in market which can take care of all these issues for us. And very good example of this is an offering from Docker itself, which is known as Docker Swarm or Docker Stack as well. So Docker Swarm is an offering from Docker Inc., but it did not gain that kind of popularity. The next offering was from Google, which is Kubernetes. The next one is Red Hat OpenShift or Nomad Server or Rancher and Messer. So these are the kind of different orchestrations on top of containerization environment. So you can have orchestrations on top of VMs as well, but these different kind of orchestrations that shown here are actually an orchestration on top of containerized environment. Out of all these orchestrations, we had Kubernetes, which gained the popularity because it being open source and quick adaptation to the team, and it is actually being well tested by a lot of organizations. So if you see, most of the organizations are now adapting Kubernetes. So Kubernetes is the need of the hour right now. Okay, so let's see what Kubernetes is and how is it how it takes the concept of Docker containers and take it to next level by creating a couple of different resources. So before going ahead, I would just want to make a quick point here that Kubernetes is also termed as K8s because of the presence of 8 literals which comes in between K and S. So yeah, it's we call it as Kubernetes. And Kubernetes takes the concept of Docker container and create something known as a pod, which is the fundamental unit of your Kubernetes cluster. So in prior to Kubernetes, you had containers. Containers usually run one single application, although they can run multiple applications inside them. But then Kubernetes took that concept from single application concept to multiple application concept inside a pod. So in Kubernetes, the fundamental resource is your pod. And a pod usually contains one single container, but it can contain multiple containers. And I don't want to get into depth of what are the criteria that you pick multiple containers inside that, but what you can think of pod as a wrapper around wrapper around Docker container, but it can contain multiple container inside that. And this is the fundamental concept of Kubernetes. So Kubernetes try to bring pod to every single resources that it has. So be it deployment, be it replica set, anything that you can think of is actually a pod in Kubernetes. And this pod is known as resource, and all the all the containers inside one single pod shares all the different kind of namespaces that are there. So as I mentioned in my previous slide, that there are different kind of namespaces which Linux offer. So all the Linux namespaces which are specific to that pod are actually shared across two different containers which are present inside that pod. So that's the quick overview of what how Kubernetes takes the concept of containerization to next level by introducing pods. And these are also known as Kubernetes resources. So pod is one of the Kubernetes resource. Other Kubernetes resource could be services, replica set, load balancer, and deployments. And each different Kubernetes resource fulfills some other needs. So pod is the fundamental unit. Service is a fundamental abstraction over offering. So let's say you have a pod which is offering application hosted on port 80. You cannot access this application on port 80 unless you have a service. So basically you create a service which will connect your application running inside a pod, inside a container, to application outside it. So that you do through service. Then there are replica sets, as I showed. If you want to have a couple of deployments of same type, then you create replica set. On top of replica set, you create load balancer. And in case if you want to have rolling updates or upgrades, then you have deployment resource. So these are the different resources which are there in Kubernetes. Again, for abstraction of this presentation, I won't get into all those things, but I would I would like to make you understand about the different kind of Kubernetes architecture or deployment strategies which are there. So what you do is to write the definition of these files, you actually write these definitions inside a YAML specification, and that YAML specification is again very simple. You just have to give a couple of things which are predefined, and once you define that YAML specification, you just give that YAML specification to your cluster, and then cluster takes care of everything as in every single thing of scaling it, of taking care of downtimes and stuff like that. So Kubernetes comes handy in that case. So you don't have to delve into the depth of what is going wrong with the cluster, but you have to just work on if your application is okay. So this was the basics of fundamentals of Kubernetes. And next, I want to talk about the architecture, because to understand the attack scenarios which are possible on Kubernetes, you need to understand the architecture of deployments as well. So Kubernetes is again a master server. Sorry, it's a master and client model. Master has definitely different duties as compared to client, and client is actually responsible for a lot of things. So let's see what are the responsibilities of client and master. So in master, you have the most important component of Kubernetes, which is Kube API server, which runs on port 6443, and it runs on SSL. And this is, you can call it as the main manager of your entire cluster, Kube API server. And Kube API server is actually responsible for taking care of deployments, taking care of where to schedule the pod and stuff like that. But it cannot take decision on its own. So it needs some sort of helper services, which is like Kube Scheduler, Kube Controller Manager, and stuff like that. So it takes the decision of scheduling with the help of helper services, which are Kube Scheduler and Kube Controller Manager. I just want to specifically emphasize one thing here, that all these services or all these different components of master also runs as a pod. So these components are again pod, and these pods interact with each other. Okay. The next thing, Kubernetes master has to keep track of every single thing which is going on, as in like which nodes are healthy, which node has which pod, and which pod has which service, and which service is mapped to which pod, and stuff like that. So every single changes which are happening to cluster, either at the pod level, either at the node level, are stored in a database which is known as HCD. HCD, as you know, is a distributed cluster NoSQL database which can help you store some values. On the other side, if you see, we have client. Now, each client will have a service again running as like basically each client will have a service running as each client will have a service which talks to your Kube API server. So Kubelet is the major service which receive requests from Kube API server. Kube API server just delegate the request to Kubelet, and Kubelet is responsible for performing them. The another important service that runs in client is kubeproxy. Kubeproxy is actually a service which helps you expose your services running inside a pod to outside of it. So kubeproxy talks, you can think of kubeproxy as a service which can help you connect to your services running inside pods. And on these things, on these things, you can think of like this architecture can be scaled on master as well. So each you can have multiple replicas of master, and you can have multiple clients. They will not be replicas of each other. And these master basically, so let's say you actually issue some commands through kubectl, and you use, I mean, kubectl transform that commands in some sort of REST API notions, and those REST API notions talk to Kube API server. So let's say if I issue a like pod create command, the command will go to Kube API server. Although it is like you have authentication and authorization on top of this Kube API server, but think of it as a very basic flow. So you issue a command through your system, which has connectivity to the master. The master will check with kube scheduler. Master will also check with kube controller manager, HCD, and it will receive green signal from them. And after like receiving data from them, it will take care of scheduling those pod or the request which comes from the client to actually schedule a pod in a client node. So here, if you see, I am issuing a kubectl, like basically a command from my system to schedule a pod, and this is how the flow goes in. So it's the responsibility of master to schedule basically a pod inside a client. And if everything is okay, if the pod is perfectly scheduled, the response comes back like back to the system, and it says, okay, everything is scheduled properly. So this is how the architecture of Kubernetes is. In this, we have one more component, which is persistent storage. So the most important thing to note here is that we don't have storage lying on machines. We have storage lying somewhere else, which is like cloud storage. And that cloud storage is available on demand. So let's say if a client or if a pod requests a storage, the storage is granted to that particular pod from the cloud storage. So this is how it goes. Okay. The next thing I want to talk about where this infrastructure is deployed. So underlying infra. So underlying infra can be completely physical, or you can actually deploy this cluster setup inside a physical machine, set of physical machines, or you can install it in a set of virtual machines, which I have deployed in my case to show the demonstration for this particular talk. Or you can have it in private, you can have it in public cloud, and you can have it as a hybrid cloud, as in some part of it is like in public cloud, some part of it is lying in private cloud. So you can have that kind of infrastructure as well. If you're going with public cloud infrastructure, there are a couple of things that you need to take care of, So I want to talk about those kind of things, like which are possible in case of public cloud and private cloud, and managed and unmanaged cluster deployment. So let's talk about the deployment strategies here. There are two basic deployment strategies with Kubernetes cluster. One is managed and the another one is unmanaged cluster. The unmanaged cluster is the one where you by yourself create a master node with kubeadm in it, and you create a cluster node. You create a client node which joins your master using kubeadm join. If you go by this strategy, there are issues with the strategies. One is you have to manage like components. In case of patching, you need them, like you need to implement patching. RBAC is easy. This configuration is difficult to implement and stuff like that. So it's not recommended to use unmanaged cluster at all. And we have a lot of services, Kubernetes services as offerings from all different kind of major cloud vendors. So with Google Cloud, GCP, we have GKE, which is Google Kubernetes Engine. With Azure, we have AKS, which is Azure Kubernetes Service, and with Elastic, with AWS, we have EKS, which is Elastic Kubernetes Service. So these comes as offering to us, as in we just have to specify a couple of configurations, as in how many nodes do we need, what are like underlying infra of that particular node, how is not node that interacting to different kind of services, like as in the firewall rules for that node. So we'll have to just perform some sort of cosmetic changes on the nodes through UI or through command line, and then deployment will deployment engine will take care of it. So I want to specifically talk about a scenario of Google Kubernetes Engine here. So Google Kubernetes Engine provides you two different kind of two different kind of deployment strategies. One is completely private, the another one is public. I don't want to talk about different strategies which are like private but accessible through public node and stuff like that. Just want to discuss two different deployment strategies. One is public and the next one is private. And I will tell you what sort of issues comes up in case of publicly accessible deployment. So let's see what publicly accessible deployment is first, and we'll see the issue with that. Okay, so we know this is our Kubernetes cluster setup. We have a master node, we have a client node, we have persistent students, stuff like that. Now, in case of publicly accessible deployment, or in case of any deployment which comes with GKE, you have two different kind of VPCs here. One is completely Google managed VPC, and another one is your project VPC. So what GCP does is GCP creates a managed VPC in which it hosts your master node, and the client node belongs to your project VPC. So in any way, you cannot directly access the master node of that GKE cluster. So this is how it goes. But let's say if you want to access that particular master, what you do is you expose that particular master APIs through Google Managed Load Balancer, and you basically hit that load balancer to schedule a pod inside that particular client node. So basically, this Google Managed Load Balancer is publicly accessible, and this publicly accessible load balancer gives the flexibility to machine which are on internet to talk to these APIs. But definitely, you cannot talk to these APIs directly. What you do is there is a cluster configuration that you have to fetch. The person who have access to the cluster configuration can only talk to this particular Kubernetes cluster. But the issue with the security issue that comes up with this kind of deployment is that, let's say someone copies the cluster configuration from your system to another system. So this is a very basic indication of insider threat. So let's say you are about to leave an organization and you just copy the cluster configuration from your system to somewhere else. So basically exfiltration of data from your machine, provided that there are no DLP solutions in your machine. Then if someone copies that cluster configuration in someone else's machine, now since this Google Managed Load Balancer is publicly accessible, that guy can also access the same API, and that internal user would be able to access. So this is a very basic case of insider threats. If your application, if your cluster is hosted as public cluster, there are good chances that it is possible, it is vulnerable to insider threat attacks. So these kind of deployments are not at all definitely encouraged. And yeah, so that's why we should not have publicly accessible GKE at all. The solution is to have a privately accessible GKE, and privately accessible GKE, what you have is you have a jump box, and that jump box can only talk to your Google Managed VPC control plane. And you talk to that jump box through a VPN tunnel. And since VPN tunnel is actually linked to your access, as in if you leave an organization, you will not be able to access that VPN tunnel at all. So that's why if in case you try to access this VPN tunnel, or basically this cluster, once you move out of the organization, those kind of issues are not there. So there are very basic changes around private, like if you see, there are very basic changes around public and privately accessible GK, which is like presence of jump box and VPN tunnel. That's why it is encouraged to have private cluster GK instead of the public one. So this is the recommended way of using managed cluster as well. Although managed cluster can take care of a lot of things, but these kind of decision is like what the administrator of the cluster has to take. Yeah. Okay, so I want to talk about a real web application attack in Kubernetes cluster, that is SSRF. So SSRF as it stands, it's like server-side request forgery, and it exists in application which are trying to send and so which are trying to send a request on the server side. So I don't want to get into what SSRF is, but I would like to try to show you that in Kubernetes environment, how SSRF can be exploited to get access to a lot of things. But again, for that, we need to understand how services inside Kubernetes cluster talk to each other. Okay, so we have a master, we have a client, and we have pods running inside our master and client. So even if you see the Kube API server is the Kube API server is nothing but a pod, and your application is also running inside your node. Now, let's say this particular application which is running here is SSRF vulnerable. Okay, now what might happen? What might happen is if this application is vulnerable to SSRF, attacker can create a payload to perform an SSRF sort of attack to actually make requests to these APIs which are running on the master node. Although this is not really simple, but it is possible, and this is only possible because of what we call as service network mesh. So I want to take some time to discuss about what service network mesh is. So Kubernetes have something called as network mesh, as in each pod inside Kubernetes container, cluster, can talk to all other pods inside Kubernetes cluster, irrespective of the namespace which they are in. So when I'm talking about namespaces here, I'm talking about the Kubernetes namespaces, not Linux namespaces. So what are Kubernetes namespaces? Kubernetes namespaces are just virtual boundaries around Kubernetes resource. So let's say you want to club a couple of Kubernetes resources together, you actually bound them to a specific namespace. But even if they are bound to a specific namespace, they can access resources out of their namespaces as well. When I say resources, as I mentioned, there is a specific Kubernetes resource which actually exposes your services out, that is service resource. So you can actually access service resource across your Kubernetes cluster, irrespective of the pod it is scheduled in. So that's the design of Kubernetes, like Kubernetes service mesh. You can access all the services inside that Kubernetes cluster. And this is possible because of a service running as a core DNS name service. That core DNS name service, like when you create a service for a pod, so let's say you have this particular pod, and pod is exposing application running on port 80. You create a service for it, and once you create a service for it, you actually send request to core DNS server to give a namespace to it. You give FQDN to it. So basically, if you have a service, you get an FQDN from this core DNS namespace server, which is running inside Kubernetes cluster. And then you get a namespace for SVC1, SVC2, and SVC3. This this FQDN has a specific notion. I'll show that notion, what that notion looks like. But yeah, each service inside this Kubernetes cluster have a namespace. And in case if your application is vulnerable to SSRF, there is a good possibility that this vulnerable SSRF application can access other services inside the Kubernetes cluster. So I would like to show you a quick example of that. So I have a Kubernetes cluster, like three node Kubernetes cluster running inside my virtual machines. Out of this, we have like one master node and two worker nodes. And in these two worker nodes, we have these many pods running in the default namespace. So let's say if I just get a namespace, you can use this command to get the couple of namespaces which are there. And today for this demonstration, I would like to pick this image is Kubernetes goat to show the different kind of scenarios which are possible. This is really really good tool to if you want to learn more about different kind of exploitation scenarios in Kubernetes. So these are the different kind of namespaces which are running. And let's say if I just want to get the name of services which are running. So these are the services which are running inside my Kubernetes cluster in default namespace. So default is a namespace, and we have these many services running. This is a service that I have created recently to show you, like if there is a SSRF in your application which is running inside Kubernetes cluster, it can access this service as well. So let me take you to vulnerable applications. So this is this is one of the applications running inside this Kubernetes cluster, and this is SSRF vulnerable application, actually designed to be SSRF vulnerable because it's a playbook. And in this particular SSRF vulnerable application, let's say if I want to access my service, which is Nginx service, let me take you back to the service. So this is the service that I have created. In this, I'm creating a wrapper around Nginx pod. I don't want to get into that, how the wrapper is being created, because that's another concept in itself. But let's say I'm exposing port number 8080 and I'm targeting port number 80 of the pod, which is running Nginx. So this is the service that I have created. And this service have nothing to do with this particular service, which is running on port number 10.0.0.10 on the, host this and port 1232. But what I can do is I can actually access this service, provided that this is SSRF vulnerable. I can access the Nginx service through this FQDN. As I mentioned, like in Kubernetes, this core DNS gives you a fully qualified domain name all the time when you create a service. So this is what it comes to. So one is the name of the service. So name of service is nothing but the name that we gave here, which is this one. This is the name of the service.
Hi, Rohit. Sorry to interrupt you. Actually, your terminal is not visible.
Oh, is it?
Yes.
Let me try sharing the full screen then.
Yeah,
I was sharing full screen only.
For some reason, your terminal was not visible. Now it is. Please go ahead.
Okay. Okay. So I'll just so I have created this service with the name Nginx, and you can actually give the name of the Nginx here. The next next component that FQDN that comes to be is like the namespace. So since my service Nginx is running inside the default namespace, so it like default is the namespace name. The next one is the name of the resource, which is SVC, and cluster.local is nothing but which is appended by this core DNS. So basically, you can think of this as like TLD for this specific cluster. So if I access this resource, like I would be able to access, because this is what service mesh architecture talks about, right? So let's say if I just perform a get method call on this service from one of the other pods, I should be able to get something out of it. So I'm getting, let me see, why is that the case? Okay. For some reason, this is throwing exit 7. Okay, let's skip it for some time. So yeah, that is the possibility of like having SSRF in Kubernetes environment. So yeah. Okay, so the next like most exploited scenario that we have, I want to talk about is like DIND exploitation. DIND is nothing but a concept which talks about like how you can call Docker services inside a Docker itself. So if you see my previous slides, I mentioned that Docker uses a concept of Linux namespaces. So let's say if you have already abstracted that namespace out, if you go inside the Docker, you won't find those namespaces again, provided you use DIND. So let's say if you want to run applications inside Docker itself, then you use if you want to run Docker inside Docker itself, then you use a concept known as DIND. And DIND is really popular in terms of like GitLab or GitHub pipeline. So let's say if you want to build a Docker image, what you do is you create a GitLab pipeline and the base image is Docker itself. And inside that Docker, you build another Docker. So basically DIND is for that. But to understand how DIND works, you have to understand how Docker command line works. So let's say if you issue a command to Docker, like through Docker, let's say you want to run a basic shell inside this Alpine container, what you do is just simply request for a Docker run alpine.sh. And once you run that command, this Docker command, which is nothing but a Docker client, this Docker client talks to Docker server through this socket, which is running in your host machine. So your Docker socket is running on var run docker.sock, and that socket talks to your Docker engine. And since it is nothing but a create command, basically it is requesting for you to create a Docker instance. So this Docker engine receives commands to this socket and simply schedule like execution of a Docker container. This is how it works, and it is very basic, like the very basic concept of how Docker works. But the issues start ticking in when you actually do this particular scenario. In this particular scenario, what I'm trying to do is I'm trying to create, like not create, basically mount the socket from your Docker host to some location inside your container. And this is you have to do for DIND. See, we are not exploiting DIND as of now. What we are doing, we are actually creating a platform for DIND exploitation, which is giving this Docker access to the socket inside host. So once you do this, basically your socket, which is this, is available inside this container as well at the same location. So basically, your application now can access this socket. And once it accesses this socket, it can talk to the Docker engine. And usually this does not happen because you know the GitLab pipeline that, let's say if you're talking about the GitLab pipeline specifically, you know the GitLab pipeline that you are creating. And once you create that pipeline, basically you know that the Docker which you are running. But let's say if you are running, if you don't know the Docker image which you are running, which is possibly the case of, like most of the time it's possibly the case with supply chain attacks. By some means, let's say, let's ignore how, but by some means, vulnerable Docker comes in your Docker engine, and by mistake you actually appended this Docker socket inside this particular application. Now what will happen is, since this application is vulnerable, this will try to access the socket which is there. And since it can access this particular socket, it can talk to your Docker engine, which is running inside host. Again, this is not running inside your container. This is running inside your host only. You can actually talk to Docker engine, which is running inside here. And once you can talk to this engine, you can actually talk to other containers which are running uh, inside this particular environment of Docker engine. So this is DIND, and this is how DIND can be exploited. Now, I have a very basic application that I have created here. Is nothing like not I have created here. So it's part of Kubernetes Goat only by Madhu. So I'm taking that as a reference. And this application is vulnerable to command injection. So it's by design actually. So let's say this is vulnerable to command injection. Yes, it is vulnerable to, and the services are running as root inside it. Now let's try to see what all mounts are there to just see if this Docker socket had been mounted on any of the Docker container or not. So I'm just checking if the mount is there or not. So let's inspect the mount, and you can see that there is some like this Docker socket is mounted to some location, and it's on tempfx, and that's a read write. So actually you can perform write operation on top of it as well. And what I will try to do is, since this application is running inside this container might not have Docker client installed here. So what I would try to do now is I would try to install a Docker client through this command. Now what it says is it will just perform a simple wget from the Docker repository to download Docker client, and it will install this, not install, it will just download this inside temp folder. Now it might take some time because it's a download operation which is happening. So yeah, let's wait for this to get downloaded. In the meanwhile, we can take some questions if there are any, because it will take some time to download. So Bablu, do we have any questions? Like you can pick them.
No, currently we don't.
Okay.
Yeah.
Because yeah, this will take some time to download. It will be close to like 30, like some MBs, and it will take some time to download. But yeah, so see, the download is complete. The next operation that I'm going to do is to extract it. I should have it somewhere. Okay, so see, since I've downloaded that tar.gz file in the temp file, I would now try to extract it. Again, this would take some time. And once I extract it, the Docker CLI will, like CLI, when I say, it's like the Docker client, which is this particular one, which will be available inside this particular application. And once it becomes available inside this application, I will use this Docker client inside this application, which is running inside the container, to access Docker socket, which is mounted. As we already saw, the Docker socket was mounted in some location. We'll pick that to actually fetch another container which are running in the host engine. So let's wait for it to get uncompressed. It's running. Again, see, this is only possible because this application is like vulnerable to command injection. Here it is like vulnerable by design, but let's say if your application is vulnerable to command injection, or if you don't have access to this container inside, or like if you don't know what container you are running and stuff, this might be possible in those cases. And yes,
Rohit, so, Dishant is asking, without client, we can't mount Docker, is it?
See, the mount is possible. So like this volume or this particular socket is already mounted, but how you can talk to this particular socket? So only Docker client, which is like Docker client application, can talk to this Docker socket, right? That's what Docker command does. So Docker command in the backend talks to this Docker socket. But if you see inside this container, we don't have this Docker socket Docker client, right? The container might not have, like if the container is having that client, then that's well and good. But if container doesn't have, how it can talk to this particular Docker socket? So we need to have Docker client installed. And that's what we did, right? So we actually downloaded and unzipped that particular Docker application inside this. So if I go and see the location of if I just see what are present inside 10, I can see that I would find Docker. And if I go again like this, you can see the presence of different kind of container binaries. Now I have my Docker client inside this application also. And what I'll do is I will use this Docker client to talk to Docker socket. So again, the command is very simple. You just have to perform like Docker, which is this one. Then you use -h option to specify the socket that you want to use. So since my socket was mounted was on custom Docker instead of var run Docker, so I'm using that socket with -h option. And then I just want to get the list of all the like Docker processes which are running. So if I submit it, I'll get the list. See, these are different Dockers which are running inside your host, not inside your container. But I was able to exploit it to like get the access to the different containers which are running inside your host. So that is the exploitation of that DIND. Okay. The next thing that I want to tell I want to discuss is secrets. So in Kubernetes, secrets aren't secrets actually. So what I mean by that is, let's say if you create a secret with this particular command, kubectl create secret, generic secret, the name of the secret, and from literal parent foo, you will notice that the secret is available as base64 encoded field. So let's say if I go to the terminal and if I just do kget secrets, I'll get the list of all the secrets which are there inside my default namespace. And one of the secret is this. So let's say if I just do kget secrets and secret name, so I'll get that secret only. But let's say if I just do that, YAML, what I'll get is I'll get the entire secret in itself. And that secret is having a value, a key of foo and the value of something. But that value, if you see, let's say if I just try to decode, it, that is nothing but a base64 encoded value. So that's the thing. So in Kubernetes, secrets are not encrypted. Basically, they are encoded, and that encoding is base64. So if you are trusting secrets to keep some sort of sensitive information, I would suggest give it a thought, because in Kubernetes, secrets are not at all encrypted. They are encoded. And if you want to have some sensitive information, the best suggestion is to have encryption first on that secret and then store the encrypted value. And in your application logic, you take that secret and then decrypt it. So this is the recommended way of dealing with secret inside Kubernetes cluster. And the last thing that I want to talk about is RBAC. And before talking about RBAC, let me take you to this particular scenario. So in Kubernetes, this is how it is designed. In Kubernetes, there are service accounts, and service account are linked to pods. So let's say if you want a pod to access any of the Kubernetes APIs. So let's say if we have Kubernetes API server, let me pick it from here. Okay, so let's say you want this particular pod to access some of the APIs which are running inside your master. So that is possible inside Kubernetes, and that we do through service accounts. So in Kubernetes, that is possible, and that is very frequently used in development or let's say staging environment or even production environment to access some sort of like health statistics and stuff like that. There are a lot of use cases for that. Not going into depth of it, but yes, in Kubernetes that is possible. And once you do that, what happens is Kubernetes actually simply copy paste that resources from your master inside that particular pod. So let's say I have a web shell of a pod, this particular pod. So I can access stuff inside this pod. So if I go to this location where run secret kubernetes.io and then service account. So this is a location where Kubernetes will mount your service account in case if you provide any service account access. And if you do that, sorry. And if you just do that, you will see the presence of different kind of things, which is like CA certificate, token, namespace, and stuff like that. And using these couple of things, just like you have client certificate now, you have namespace access now, and you have token as well. So let's say if I just print token here, you basically have the authorization header token, which you can use to talk to Kubernetes APIs directly. So if there is a pod, and by mistake in this pod, you give access to a service account, which have access to entire cluster, then you're gone. Basically, if this pod becomes vulnerable by any way, then your cluster becomes vulnerable. So always make sure, like if you are giving access to resources inside Kubernetes cluster, like through service accounts, just always make sure that you don't give over access in that case. So here, if you see, most of the accesses are given, and all these access can lead to read write to Kubernetes cluster as well instead of just pod. So yeah, this is what the concept of RBAC is. Instead of giving whole set of permissions to actors, what you do is you create actions. Like we have a lot of actions on Kubernetes. One is list, get, create, patch, batch, watch, and stuff like that. And on those resources, what you do is you try to restrict the access through RBAC. So RBAC, basically you implement RBAC through a set of policies, and you write policies to create like restrictions on service account, which you want to share across pods. So that's the most, like that's the best restricted way of doing it, because once you give service account access to your pod, then your pod can access the entire cluster. And in case the pod is vulnerable to something, like let's say command injection or something like that, or even SSRF, then your pod can access APIs which are which it should not access, and it can lead to cluster damage. So yeah, there are other set of attacks also possible with Kubernetes, but I think for this particular like presentation, I want to restrict like them to these kind of attacks and scenarios. Yeah. So yeah, thank you so much, guys. I hope you enjoyed it. I tried to make this presentation in very zine way, in like following the theme of security zines. And again, special thanks to Kubernetes Code, which is a good like vulnerable application design for Kubernetes by Madhu Akula, and the Dynamics CISO team for like inviting me here. So yeah, thank you so much. Thank you so much, guys. That's it. Like yeah. That's it from my side.
Yeah. First and foremost, I would like to say sorry to all the viewers who had to wait for some time. Actually, we had some technical issues in the beginning. I hope you all were still able to join later. That said, we are recording this, so we will upload this video to YouTube after some time today, and we will let you know. Apart from that, great talk and the demonstration. I'm in awe of your graphic skills, the security giants that you create. Amazing. And we have a question from the viewer. Vishal is asking, what would be the risk level of exploitation of a vulnerable component, not just the demo app?
Okay, so as I like, if you see in this demo application also, there are vulnerabilities that we picked specifically. So one was SSRF, another one was command injection, and these kind of vulnerabilities may exist in your like applications which are running inside the cluster. So the same would propagate, I would say. Yeah. See,
So,
this is like
mhm.
it's like we are ensuring that like we have to definitely implement web application like web security controls. Definitely, we cannot bypass them or cannot ignore them. Definitely, we have to take care of them on top of these kind of controls. Yeah.
Okay, great. Thank you so much, Rohit, for sharing these valuable insights on Kubernetes security and answering these questions. Guys, if you like today's talk, please do let us know, and we will be happy to continue doing these LinkedIn Lives. That's all for now from us, and we will see you in the next episode of LinkedIn Live with some great InfoSec topics and awesome speaker like today. See you soon.